Hi, I'm Terry Camersell, and I'm here on behalf of Creation Fellowship Santee. And we're a group of friends who love to learn about our Creator God. We used to meet for 10 years in person at the Creation and Earth History Museum in Santee, California. Then, and online, our goal is to equip believers to defend their faith. Most weeks we have speakers joining us with a presentation, and we love doing that. But tonight we have a special treat because we have with us Dr. Jason Lisle of the Biblical Science Institute. He's an astrophysicist, and he is actually going to just be doing a Q&A. So an astronomy themed Q&A. So over the past week, we've received some great questions, and our friend Steve Hendrickson is here to ask those questions. If you're watching along on Facebook and you have more questions that you'd like to ask, you can feel free to put them in the comments and we'll be monitoring them, but only as time permits will we be able to ask them. We do have quite a few good ones lined up. So without any further delay, let's get started. Go ahead.
Okay, well, thank you for being here, Dr. Lisle. I'm sure that a lot of people like to hear an expert answer the questions they have. And so I'm going to start out with the first one from Daniel M. He says, what are your thoughts on archaeoastronomy? How reliable of a dating method is it? How should Christians and creationists respond when the dates given by archaeoastronomy methods do not line with the biblical YEC or YEC position?
It's a very useful tool. It's when we use the predictable motions of the stars, the planets, and so on, and recorded history or archaeology to figure out when things happened in the past. And I find it's a useful tool, and it's a clever tool, but the right assumptions need to go into it. And occasionally you'll get a number that it's, you'll hear a number that's reported based on that's off, and I double check it. That's what I do. So if it's something that doesn't line up with the biblical timescale, then there was a false assumption made. I've heard about the construction date of the pyramids, and this is something that I checked out myself based on uh, the fact that there's a shaft in the pyramids that points very close to where the North Star is, the North Celestial Pole. It's just a little bit below it. And at the construction of the pyramids, there was no North Star because the Earth's polar axis drifts over thousands of years. This is called precession of the equinoxes, and we know what causes it. It's caused by tidal forces, but it happens at a predictable rate. And so there was a time in the past where we would have had a North Star, Thuban, around the time of Noah. Thuban would have been the North Star. Now the axis uh, of the pyramids is not directly on that; it's off a little bit, and so Thuban would have fit in that little hole. But there's two solutions to the problem. One's pre-flood, which can't be, and one is post-flood. And it actually lines up pretty well with the biblical timescale. So it's funny because I've heard people say, well, based on archaeoastrology or archaeoastronomy, you can pin down the construction of the pyramids and it doesn't line up with the biblical timescale. I've done the math and it does. There's two solutions. One of them can't be, but the other solution lines up perfectly fine. So I think it's a very useful tool, providing the assumptions that have gone into it have been correct. And there are structures like Stonehenge where there's debate about exactly how these things were meant to function and so on. So you got to be careful about that. Yes, you can pin down the age of those things if the assumptions that you make are correct.
Okay, good. Thank you. The next question is from Erica D. She says, both my kids are doing Science Olympiad, and one of their events this year is the solar system. Two of the topics they have to study include the age of the planets and how they were made. My oldest is mainly concerned about failing those questions for answering honestly. She knows the truth, but would like to back up her answers with scientific proof. She doesn't want to let her team down, but she also wants to give a biblical answer. They will be looking for Big Bang and billions of years old, obviously.
So, yeah, my answer to this is going to be a little nuanced. When you're in school, you're there to learn. You're there to learn what you're being taught, and the grades are based on the teacher's assessment that you have learned what has been taught. That grades should not be based on your worldview, your beliefs. whether you believe what has been taught. And so and there are ways to do this where you can give the answer that the teacher is expecting, showing that you have learned the information, but without revealing what your belief about the situation is, whether you embrace what the teacher has taught. And so you can say things like, it is generally accepted that the solar system is 4.5 billion years old. Now, that is a true statement. It's not true that the solar system is 4.5 billion years old, but it's true that it's generally accepted that it's 4.5 billion years old. Or the consensus among the majority of astronomers is that the solar system is 4.5 billion years old. And you can even say what that's based on. You can say this is based on the nebular hypothesis and radiometric dating of meteorites and things like that. So you can say that, and you can even put, depending on how ambitious you want to be, you can even put some challenges in that. You can say there are data that are inconsistent with that, or that have challenged scientists' beliefs, and there are counter explanations for those. And you can go into some of those, like the internal heat of Jupiter, which is not really consistent with the billions of years. One of the textbooks I have back there that I used when I was an undergraduate, written by Ted Snow, who I later got to know personally because he works at the University of Colorado, or he did when I was in grad school there. He's honest about that. He admits that the heat problem is a problem for an old solar system. You could even quote him. And so, I mean, and that would be perfectly kosher because he does believe in the billions of years, the 4.5 billion years, but he's honest about the fact that there are some challenges, that there are some data that seem to challenge that view. And I think that's a very honest way of approaching it. And if you do it right, the teacher won't know what your view is. So that's the way I would approach it. Be a journalist, fairly report the information, and don't try to persuade the teacher one way or other. Just here's what's generally believed. Here are some facts that some astronomers have admitted have challenged that. And so you're given both sides, and then that's all you need to do.
Okay, well, I think that's a great answer, Jason, because it's the one I would use. So just thought I'd help you out there.
Well, good.
Okay, next we have Carol P. She says the Almagest astronomical treatise, 150 AD, Ptolemy argues that theoretical philosophy must be divided into three categories: the physical, the mathematical, and the theological. If I'm understanding him right, he then admits or attempts to illustrate that only mathematics is a reliable, unchanging approach to the understanding of the universe, though, of course, we know all three categories are complementary and necessary. How did the early church respond to this splintered perspective of astronomy? Was there a Christian rebuttal to Ptolemy's secular treatise, or was it commonly accepted as the ultimate authority on astronomy at the time, even by believers?
Ptolemy was very well respected as the last of the ancient Greek astronomers. He's actually 150 AD, so he's after Christ's earthly ministry, whereas most of them, like Aristarchus and Eratosthenes, those were before Christ's earthly ministry. So the Greeks were very well respected. My guess would be, and I'm not an expert on church history, this would be a good question for Dr. James White, for example, but my guess would be that they did not challenge that. Now, the Apostle Paul, understood that Greek philosophy had its problems and was not, it was something that needed to be challenged and replaced with biblical philosophy. And he did so in Acts 17 when he challenged the religious philosophers, the Epicureans and Stoics. Those were two very common schools of Greek philosophy that existed at that time. He challenged them. He challenged their worldview. He pointed out that some of their philosophy embraced things that only make sense in the Christian worldview. And he pointed out that some of their beliefs are inconsistent, and then he demolished their worldview, replaced it with the biblical one. And you would hope and you would think that early Christians did that, but as a matter of historical fact, the church from very early times was infected with Greek philosophy. Christians had everybody had high regard for the ancient Greeks, and don't get me wrong, there are things to be commended about Socrates and Plato and Aristotle. Don't get me wrong, they discovered some neat things, but their worldview wasn't biblical. And there was a tendency for Christians to think, well, these great minds, they were just really close to being Christian because they were so brilliant and so on. Well, they discovered some good things, but they had some false beliefs as well. And the division of philosophy into physical and mathematical and theological. That wasn't unique to Ptolemy. That was an ancient Greek philosophy. Aristotle held to that. Aristotle held to that as well. Aristotle put theology as the most basic, which I would agree with, but he just didn't have the right theology. But he did have, there was the philosophy of the prime mover and so on, and a lot of Christians adapted that and said, well, that's God. God's the prime mover and so on. But it's not quite the same. It's not quite the same. My guess would be Christians did not push back largely on that. They probably, since there was disagreement among the Greeks as to which category was primary, um, they probably would have allowed for that as well. But see, I as a Christian and as an amateur philosopher would say theology's most basic, right? Because theology is where we get mathematics. Mathematics is the way God thinks about numbers. Theology is where we get the physical universe. That's the creation of God. So mathematics and physics are subsumed into the larger theology. The problem with Aristotle, see, Aristotle believed that theology was primary too, but the problem is he didn't have revelation. He did, but he ignored it, right? He didn't consult the Bible. And that was Ptolemy's objection to making theology primary, is because it's so conjectural. How do you know anything about God? Well, if God didn't reveal himself, you don't know anything about God. So, but we Christians have revelation from God, and that is more certain than mathematical truths. You see, but mathematical truths are certain only in so much as they stem from the mind of God. So when you're doing math, you're really doing a branch of theology. You're learning to think about numbers the way God does, in a limited, finite way, of course. But yeah, Ptolemy didn't like the physical because it could change. He assumed that mathematics was unchanging, but how does he know that? See, apart from the Christian worldview, how can you know that mathematics doesn't change? The best he could say is it didn't change in his past experience, but his past experience is limited. And he doesn't have experience of the future, and yet he assumed mathematics would continue to work in the future. Whereas I, as a Christian, because I'm basing my philosophy on revelation from God, I can say, the Bible says, God, I, the Lord, do not change. Therefore, you sons of Jacob are not consumed. God doesn't change. Mathematics is the way God thinks about numbers. Therefore, mathematics doesn't change. God allows the physical universe to change. The Bible's clear about that. And so I can compartmentalize all those three, but I have it in a more biblical worldview. And my guess is most of the early Christians didn't think that way. They were very heavily influenced. And I think it's indisputable that the early church was very heavily influenced by Greek thinking. And frankly, it still is today.
Okay, thank you. And I would probably add to that what you've written on with regards to logic as well.
Mm-hmm.
Yeah.
Yeah,
Okay.
logic. Yeah, mathematics really is the logic of numbers. So mathematics, you can think of it as a subsection of logic, really.
Yeah. Okay, well, thanks. That's good. Okay, next is a question from Cheryl O. She says, please talk about the 2 times the sun went backwards and stopped in the Old Testament. There are unfounded rumors that NASA has discovered this. Thank you.
Yeah, to be very clear, the rumors that NASA has discovered that Joshua's long day or or Hezekiah's where the sun goes backwards for a period of time, those rumors are false. NASA hasn't discovered those. It's not clear to me how they possibly could. If God stopped time in the universe, if God stopped cosmic time but allowed events on Earth to occur as normal, which is apparently is what he did for Joshua's long day, and if he temporarily reversed motions in the solar system for a period of time, I don't see any way how you could scientifically verify that in the present. We know that happened because it's recorded history. It's in the Word of God. There are some legends that other cultures recorded those events. That's something I'm looking into. I haven't dogmatically said anything about that. I want to look into that a little bit more. But there are legends of a long night in the North Americas at around that time and so on. So there is independent confirmation, but not from NASA computers, because the story, and it has evolved over the years, because the story started before NASA, where there were some mathematicians trying to figure out something in the universe and they couldn't figure it out until they accounted for Joshua's long day, and then it worked. No, it's not true. And the version involving NASA's computers is not true either, because the because time in the cosmos is based on movement in the cosmos. There's no way to distinguish between the two. Time is the flow at which events happen, and and what was unique about Joshua's long day is that God allowed events to happen on the surface of Earth, while stellar motion, solar system motion at least, did not occur, or at least the relative motion of the moon and the sun relative to the Earth. So we don't know all the details of that, but that's what's recorded in history.
Okay, well, good. I didn't know a lot of that, so thank you. Next, we have Jimbo, who happens to be on our group here. He says, what do you think would the likelihood of a massive enough of a solar flare or something similar directly hitting the Earth with enough energy to generate aurora everywhere throughout the atmosphere to the point where the event would be visible to everyone on the surface of the planet?
Yeah, that could happen. Every now and then, the sun does uh, have a massive flare. The flare will trigger what's called a coronal mass ejection in some cases. It's the coronal mass ejection that causes the aurora, the coronal mass ejection, and material being blown away from the sun, enhanced solar wind activity in a particular direction. And if, depending on how it's directed, I mean, there's 360 degrees that that thing can go. And most of them are off in a direction very different from the Earth. They do tend to focus more along the equator of the sun, but rather than the poles. So that helps us, that increases the probability that Earth will be hit. And then there's two polarities. The um, uh, coronal mass ejection can have. If it's lined up with the Earth, where its North Pole is matched with Earth's North Pole, not much happens. It just kind of is deflected very gently around the Earth. But if the pole is opposite aligned, so where its South Pole matches Earth's North magnetic pole, that's what triggers aurora. And we've had some spectacular ones, even last year, because we're near solar maximum right now. So every 11 years, the sun peaks and you get more of the solar activity. You get more flares, you get more coronal mass ejections as a result of it. And we had some spectacular northern lights last year. It was really wonderful. Yeah, I got to see some here in Colorado. And Colorado, I grew up in Ohio, and I grew up at about the same latitude, but Ohio's closer to the magnetic pole, so we had them a little more often in Ohio than in Colorado. But we had some great ones. And I sent a text message to my buddy James White down in Arizona, and I said, you might want to try it, but he couldn't see any down there. So, but they have made it down that far, and those are relatively mild coronal mass ejections. Theoretically, you could have one that would cause aurora everywhere. That certainly could happen, and we're probably overdue for one like that. And it is a concern because one that is that massive could knock out our satellite grid. It could damage the satellites. Uh, not much more than that. I mean, it's not going to wipe out life on Earth or anything, but you might not be able to use your cell phone for a few days.
Okay. You've heard of the Carrington event back in 1859. Is that correct? That was a coronal mass ejection that, you know, set fires to some of the Morse code apparatus and stuff like that due to EMP.
Yeah, I've heard of such things
Yeah,
happening.
which is, I think, geophysically, it's what a lot of people are worried about
Yep.
for to happen because it could take out satellites and stuff like that and really interrupt or maybe delete the internet for a while. So that's an interesting thing to think about too. But I know from some of the lectures I've given on HEMP, which is high altitude electromagnetic pulse and stuff like that, that it's a big danger. I guess it doesn't have much to do with the um, question you were given about Aurora, but anyway, I thought I'd mention that as I was looking at that. Okay, so back to the question.
Steve,
Yes.
Steve, before you go on, I know our next category of questions is about the speed of light.
Mm-hmm.
Um, and actually, before we do that, I know we have a couple of questions about ASC in our lineup. And so we got another question just now, and somebody's asking if Dr. Lisle could briefly explain ASC before we talk more about it.
Okay.
So,
That's probably a good idea. That's a good question. I'm still working on my elevator pitch for ASC, but the bottom line is space and time are a little more complicated than most people think, and that's something that Einstein knew about and wrote about. That was his big discovery. We tend to think of time as absolute, but clocks can tick at different rates depending on different circumstances. And one of the things that's interesting that Einstein discovered is what's called the relativity of simultaneity. And that is the fact that if you have two clocks that are separated by a distance and they're synchronized by whatever mechanism, synchronized means they read the same time at the same time. They both read noon at noon. Einstein realized that if one observer recognizes, yes, they both read noon at noon, another observer in a different position moving relative to that observer using the same method would not agree that they're synchronized. He would say, no, this one's a little bit ahead of that one. It's ticking it's a little bit ahead. It's 2 seconds ahead or whatever. And we don't notice these effects because they don't kick in at the relatively slow speeds we move on Earth. We move very slowly compared to the speed of light. But they become very significant at high speeds to where one person could say these clocks are exactly synchronized, and another person could say, no, this one's 5 minutes ahead of that one. Now, what that means is one-way speeds are a little bit subjective. And what I mean by a one-way speed is the speed that you'd measure something as it travels from A to B, but not back to A, just in one direction. And in order to measure that speed, you need a clock at A to tell you when the object starts, and then you need a clock at B to tell you when it arrives. You subtract the time, and then take distance and take the distance between the two, divide it by time. There's your speed. But since whether these two clocks are synchronized is somewhat a matter of perspective, that means the one-way speed is somewhat a matter of perspective. Interesting. And that includes the one-way speed of light. So the speed of light in one direction, and Einstein wrote about this, is not something that we can actually objectively measure because we need two clocks that are synchronized to measure it. And normally the way we set two clocks to be synchronized is by light transmission, by assuming that it travels the same speed that way as this way. Einstein said, not only do we not know that, you can't ever know that. And his solution was to recognize that the speed of light in one direction is conventional. It's something we get to set. Now, interestingly, the round trip speed of light in vacuum, the speed of light going from A to B and back to A, that is fixed. That's set by God. And it doesn't matter how you're moving or where you are in the universe. Everybody will agree that when light goes from A to B and back to A, its round trip speed is exactly the same, and it's called we symbolize it with a lowercase letter c, and it's exactly 186,282.397 miles per second. It's very fast, but the speed of light in one direction can be faster than that. It can be slower than that, and Einstein recognized this, wrote about it. And what I've pointed out is that the Bible likely used an ancient convention whereby the speed of light when it's moving toward you, you define it to be instantaneous. It's infinity, and then when it's directly away from you, it's half c. And then there's an equation for other angles if you want to do that. But all ancient cultures, whether they knew it or not, used that convention because they didn't subtract off light travel time. When you see something happen, that's when it happens. And the neat thing about that convention, if the Bible's using that, and I believe it does, because all ancient cultures did, then there's no distant starlight problem because God made the stars on day 4, and their light reached Earth immediately because it's inward directed, and we've defined the inward speed of light to be instantaneous. Now, to get a signal back would take time, but we don't need to get a signal back. The purpose of the stars is to give light upon the Earth. The light only has to come one way. And so whether it's reflected back to those stars by now, that's irrelevant. So that solves the distant starlight problem. And so I've written about this. I published a technical article on it in the Answers Research Journal back in 2010. And I've got a series of articles on the website too, talking about some of the other solutions to distant starlight and why mine's better, basically.
Well, that's pretty good. Maybe a little long for an elevator ride, but okay.
Yeah, it is. That's
Okay.
well, maybe it's a tall building.
Yeah. Okay. Okay. So the next group of questions is on the speed of light. This is from Josh S. He says, do we know if the two-way speed of light is constant in different planetary atmospheres compared to our own here on Earth or in space? If it is, or could be different, how would that affect our understanding of the one-way speed of light using the anastrophic synchrony convention, the ASC?
Okay, yeah, the round trip speed of light, when we talk about, or when Einstein talks about the speed of light being constant, he's talking about the round trip speed of light in vacuum. And that's important. When light travels through a substance, it always slows down, at least the group wave slows down in a substance. And that includes Earth's atmosphere. Light in Earth's atmosphere is very slightly slower than it is in space. And I'm talking about the round trip two-way speed of light. When it travels through water, it's quite a bit slower. It's actually like 75% the speed that it is in space. When it travels through a diamond, it's like half the speed that it is in space. And that's what will cause refraction, actually, the change in the round trip speed of light, which is why diamonds are so sparkly. and why an expert can distinguish a diamond from glass or something like that, because the refraction is different in those materials. So yes, the speed of light is slower in planetary atmospheres. Our atmosphere is relatively thin, so there's very little difference. It's like 99.99 whatever percent the speed of light in vacuum. On Venus, it's a bit slower still. In water, it's slower still, and so on. So yes, it is affected by planetary atmospheres or any material. When light goes through material, it will slow down. How does that affect the one-way speed? Same way. It will slow down the one-way speed as well. It's just the one-way speed, we allow it to be different in different direction, and that tells us how to synchronize clocks.
Okay. Rob L. says, recently I came across the concept that there is a fabric to space. The idea that was presented is that as the fabric is stretched out, it takes longer for light to pass through it. Also, around objects with gravitational fields, the fabric would be thicker. All of this to say the speed of light could be faster in certain mediums, and that stretching out the fabric could account for the current slower speed of light. If this concept is correct, it could account for the apparent billions of light years in a universe that is only a few thousand years old.
Okay, I think that okay, yes, space is a fabric of sorts, which means it's not nothing, it's something. Space has properties. We tend to think of space as nothing, but it's not. You can measure it. It's three-dimensional. It has properties of dimensionality for one. Space can create virtual particles and reabsorb them, and you know, so space does have properties, and one of the properties is it can be stretched. And so if light is traveling from one object to another and it's in space and the space gets stretched, the wavelength of the light gets stretched as well. And that's usually what is attributed to the redshifts of these distant galaxies. I've recently challenged that idea, but it is certainly it's a possibility that one of the reasons why distant galaxies are redshifted is because they've traveled through space that has been stretched, and that stretches the light wave as well. Does it affect the speed of light? Not locally, not low. If you're there, if you're in a section of space and you measure the speed of light in vacuum, it will always be c. But the weird part is space itself can be stretched, and so light that would take a certain amount of time to get from A to B, as you stretch out space, that distance increases. And so for the first part of its journey, let's say to get to the halfway point, light didn't have to travel very long to get to the halfway point. But now that space is stretched, the halfway point is now bigger. The remaining distance is now bigger. So it takes longer to get the remaining distance. And so that does factor into things like expansion of the universe and so on. And there are equations that deal with this, that tell you how to deal with that. There's an equation, there's the light travel time distance. If you're wondering in cosmology why there are different definitions of distance, and it gets trippy, but that's why. It's because the space can be stretched. And so that changes the definition of distance. Is it the distance now? Is it the distance when the light was emitted? Is it something in between? And so on. So there are different, there's co-moving distance, luminosity distance, light travel time distance, and so on. And that's why those different definitions exist. When light is near a massive object, the fabric of space is such that space tends to sort of, you can think of space like the surface of a lake, and you pull the cork on the lake, that represents a massive object. Space tends to sort of funnel in to the lake. That's what a black hole does. That's why a black hole is black, because at a certain point, space is falling in at the speed of light. Objects through space can only move slower than light, except for light, which moves at the speed of light. But space can move at any speed. And so at a certain point around a black hole, the point called the event horizon, a certain distance, this space is falling in at the speed of light. And so if you shine, if a flashlight's falling in and turns on right at that distance, the light will be trying to swim out like salmon going upstream, but neither winning nor losing. It'll just sit there. So you can actually have stationary light at the event horizon of a black hole. If it's slightly off, then it'll fall in. But if it's directly outward, you can actually have stationary light. So it does effectively, it affects the global universal speed of light. But locally, if you're falling into the black hole, you would see that light still moving at the speed of light. So it doesn't affect the local speed of light. Can that be used to solve the starlight problem? Probably not. Russ Humphreys has tried that. He tried it. He tried combining it with time dilation. The problem is we know how much space expands because it produces a visible redshift, and the redshift to nearby galaxies is minimal, and they're millions of light years away. And so what that means is space hasn't been stretched very much in millions of years if you take their the secular interpretation of events. So I don't think that's going to be the solution to distant starlight, but we do have a good solution to distant starlight, the ask model, which has yet to be really refuted. It's a good model. It might not be right, but it's at least a good model. It's made successful predictions, and nobody's been able to refute it cogently.
Okay, good. All right, the next question is by an anonymous person who didn't decide to give their name, but it says, I was wondering about a cartoon that Dan Letha had recently drawn for the Biblical Science Institute concerning a discovery you made. It said that the JWST had proven that the fabric of space is not expanding, but rather the galaxies are moving apart through the fabric of space. Could you elaborate on this and what this discovery does to the Big Bang cosmology or cosmogony?
Yeah. So the Big Bang is predicated on the assumption that the fabric of space is expanding and always has been, and that it's been expanding at a certain rate, and that this is what causes the redshifts of galaxies. Now that galaxies are redshifted is indisputable, and the farther away they are, the more redshifted they are, and there's a relationship between the two, and that's called the Hubble law. The Hubble law, basically, in layman's terms, is the farther away a galaxy is, the more redshifted its light is, which means its light's been stretched to longer wavelengths. And one thing that would cause that would be expansion of space. Now, it's not the only thing that could cause that, but almost all astronomers since the 1930s have assumed that the reason galaxies are redshifted is because the fabric of space is expanding. Einstein's equations allow for that. They don't require it, but they do allow for that. And there were 4 scientists that solved Einstein's equations for an expanding universe. And the particular mathematical structure of the way that most astronomers think space expands is named after those 4 scientists. It's called the Friedmann-Lemaitre-Robertson-Walker metric. And the latest data from the James Webb Space Telescope are not very consistent with that metric. And I did some calculations. This was last year? I published it last year. The calculations were done in 2023, because if space is expanding like that, according to the Friedmann-Lemaitre-Robertson-Walker metric, it creates a sort of optical illusion, an optical magnification effect. You know how most objects, as they get farther away, they look smaller and smaller and smaller. You can see the car going away and it gets smaller and smaller. That's perspective. That's just geometry. Now, if space is expanding, that effect will only work out to a certain distance, and then objects will start to look bigger again because space has been stretched, and it creates kind of like a magnifying glass effect. And when we look at data, we look at these galaxies from the James Webb Space Telescope, I was expecting to see that. I thought that the Friedmann-Lemaitre, even though I didn't believe in the Big Bang, I thought that metric was the right mathematical description for the expansion of space. And so I was expecting to see farther galaxies that are bigger than nearby galaxies, but you don't see that. The galaxies continue to get smaller and smaller and smaller. And I thought, what happens if you don't assume the Friedmann-Lemaitre-Robertson-Walker metric? What if you just assume Euclidean geometry? Do you get the right size for those distant galaxies? And the answer is you do. You get the right size for all galaxies at all redshifts. And I thought that's remarkable. And so I published an article on this back last year, 2024, and around July, I think, in the Answers Research Journal. And I showed that the sizes of galaxies as we see them in the James Webb Space Telescope, knowing that there is massive, some of them are as massive as nearby galaxies, and yet their apparent size is exactly what you'd expect if the fabric of space is not expanding. Now, that doesn't mean the universe isn't expanding, because the other explanation for redshift is that the galaxies are moving away at fast speed, and that would do it. That would create a redshift as well. But apparently, the fabric of space does not go with them. It's kind of stationary, and the galaxies just move through space. There are other solutions, and it doesn't absolutely disprove the Big Bang, because secularists could argue that those galaxies, for some reason, are actually really small, and they've grown in such a way over millions of years as to exactly compensate for that effect. And in fact, I had somebody respond basically arguing that. And I followed up with I had a response to his paper as well. But Luke Barnes very politely challenged me and said, "Well, we think the galaxies grow at that rate." And I said, "Well, that's not likely because their masses would tend to grow too, and their masses aren't growing based on the surveys that I looked at anyway." So very exciting stuff. If I'm right, if the Friedmann-Lemaitre-Robertson-Walker metric is not correct, then the Big Bang's dead in the water because it requires that
Mm.
metric in order to squeeze all the galaxies and all the matter in the universe back to a point 13.8 billion years ago. So it'd be lovely if that turns out to be right, but this is a scientific model. I could be wrong. So let's wait and see. It's a neat model. It fits the data, but let's wait and see.
Okay, thank you. That's pretty interesting, really. All right, so the next question is a Big Bang section here we're going to start into. From Tecumseh, he says, I'm familiar with your JWST based work developing the Doppler model, but I'd like you to weigh in on the conflicting opinions and theories of scientists still using the JWST data to support the Big Bang. For example, Hugh Ross first says that these discoveries seem to be a problem for the Big Bang, but after explaining them, concludes that they confirm the Big Bang. How do you assess Hugh Ross's explanations? So that's the first part, and then he has a follow up.
Okay, so with regard to the first part, it's true that these observations don't definitively disprove the Big Bang. What they do disprove is the standard model as it existed in 2022 before these data came in, because the standard model not only includes the Big Bang, it also includes naturalistic ideas of how galaxies form and how the heavy elements formed and so on. So sometimes I use the Big Bang to refer to all of that. But strictly speaking, if you're just saying it's the idea that the universe popped into existence 13.8 billion years ago, yeah, it doesn't necessarily disprove that. But what it does show is that the combination of the Big Bang and stellar evolution of galaxies, the combination as it existed in 2022 is wrong. There's no doubt about that because it predicted that these galaxies would taper off and that there really shouldn't be any beyond a redshift of 14. The ones that do exist at that distance should be tiny, low mass galaxies, clumpy and irregular because it's supposed to take billions of years for them to become these beautiful spirals. And they should have population 3 stars, stars with no metals. All three of those predictions are wrong. And I do have to point out that I, using the ASK model, the anisotropic synchrony convention model, predicted the opposite. And my predictions were verified by the James Webb Space Telescope. So if we're doing science here, if we're applying Occam's razor, we've got a creation model that fits the data way better than the secular models. Now, what happened is after these discoveries were made, uh, they are incompatible with the ideas of stellar galaxy evolution and Big Bang. Those two together can't be right. So you got to check one of them. The one they're going to check, well, the Big Bang's their sacred cow. They're not going to get rid of that. So the one that most of them checked would said, hey, our models of galaxy evolution are way off. They need refinement. And so people have been working on that. They basically pushed galaxy evolution back to an earlier time, which is exactly what I predicted they would do, by the way. So that's probably what Hugh Ross is referring to. But did these new discoveries with James Webb Space Telescope, did they challenge the prevailing secular paradigm? Oh, yes. Oh, yes. It's just that the Big Bang, it's not a theory. It's a philosophical paradigm that can't be falsified because no matter what we discover, they'll invent a rescuing device to explain it away. And Hugh Ross is no exception. There's no discovery we could make that would disprove the Big Bang in his eyes. There's not, because that's his religion. That's what it's not based on the Bible. It's based on the Big Bang. It's based on a secular story of origins. And so, yeah, it doesn't disprove the Big Bang, but it sure is interesting, and it does challenge the standard model, and it is causing secular astronomers to revise their ideas of galaxy formation.
Okay, when you say it pushed it back, do you mean that there was this 26.7 billion years old universe? Is that what you mean?
Okay, that's not what I was referring to, although that is one solution one could take. Mostly, see, it's supposed to take 450 million years for galaxies to form. And there's an equation, if the Big Bang's true, redshift corresponds to a time And the higher the redshift, the closer you are to the Big Bang. So you get back to a redshift of 14. That's about it. That's about, I forget what the number is, but it's around 450 million years after the Big Bang, something like that. So there shouldn't be galaxies beyond that, but
Right.
they're there. And so normally the explanation is galaxies must have evolved sooner, quicker than we thought. So instead of 450 million years after the Big Bang, only 300 million years after the Big Bang, because we're finding in that higher redshifts. Now, another solution that somebody took, and I forget the name of the author, but what they tried to do is revive the tired light hypothesis. The tired light hypothesis was proposed by Fritz Zwicky back in the 1930s, back before the Big Bang was popular, because he thought that was kind of absurd. He thought that a better explanation for the redshift is that light loses energy for whatever reason as it travels through space. And there's different versions of it. There's different mechanisms for getting the light to lose energy. That would also cause a redshift, but there'd be no expansion of space. And so in that view, you don't need a Big Bang. Well, somebody recently tried to combine the Big Bang with tired light and basically said that redshifts are 50% caused by expansion of the universe and 50% caused by light losing energy. And what that would allow them to do is double the age of the universe. And so there's where you get your 26 billion years instead of 13. That's where that comes from. And I don't think that will get very far. It's an interesting idea, but I don't think it'll get very far because it violates Occam's razor. You're now having two different explanations for the redshift. And although that's not impossible, it's philosophically preferable to say, well, there's only one mechanism, right?
Okay. Okay, good. All right. So the follow-up question was, in saying the data confirm the theory, some scientists suggest that at the beginning there were only light elements. Others argue that the discoveries indicate the universe is much older than the Big Bang suggests. Where does the truth lie?
Neither, because the idea. Well, okay. So in the Big Bang model, it can only produce light elements. I've done the math for that. That was required. That was required work when I was in grad school. We had to do Big Bang nucleosynthesis. If the conditions in the universe were those of the Big Bang, the only kinds of elements that can be produced are hydrogen, helium, a little bit of lithium, maybe a little bit of beryllium, but none of the heavy stuff. Oxygen, nitrogen, that can't be produced because the conditions aren't right. The density and temperature are not right to produce those heavy elements. And so all Big Bang models, as far as I know, all of them would say that the light elements were the only elements available in the early universe. And therefore, as a consequence of that, the first stars to have evolved, to have formed from those elements, would have to be made of only the three lightest elements: hydrogen, helium, a little bit of lithium. And so it was astonishing for the secularists to detect heavy elements in these distant galaxies where there should only be the three lightest ones. By the way, the idea, if you're wondering where did the heavy elements come from, in the secular view, those are supposed to be produced in the cores of the heaviest stars, and only the heaviest stars, the most massive ones. And when they supernova, when they explode, then some of those heavy elements get distributed into space. And so then the next generation of stars now collects gas that is contaminated with some of these heavier elements. And so the subsequent generations of stars do have some heavy elements. The sun does. It has some heavy elements like oxygen, nitrogen, carbon, things like that. But the first generation of stars shouldn't have any, and therefore the first galaxies shouldn't have any. But they do. The galaxies that are the farthest out do show these heavy elements. And that was surprising for the secularists. It's something I predicted because I know from scripture that things like some heavy elements existed before the stars.
Yeah.
Because oxygen, for example, because if you look at Genesis chapter 1, verse 2, the Holy Spirit was hovering over the surface of the waters. That's on day one. So Earth already has water on it. In fact, it is water on day one. Water is H2O. O is oxygen. So I know oxygen existed on day one. Stars are made on day four. So I know that the heavy elements were already available when God made the stars. And so I would expect even the farthest galaxies would have some heavy elements in them. And that was verified. That was vindicated with the James Webb Space Telescope data. But again, some secularists, and I think it's a very few, have decided to combine the Big Bang with tired light, and that doubles the age of the universe, and that gives them a little more time to play with, more time to develop these heavy elements and so on. I don't think that'll catch on because it's invoking two different hypotheses to explain one phenomenon, namely redshift, and that's frowned upon in science because it goes against Occam's razor, the idea that the simplest explanation is usually the best.
Okay. Well, that's a good point about oxygen being there on day right away. Day one, I guess.
Actually, I'm going to jump in here for another question that just came up live. Is can you emphasize, I guess, a little more or explain a little more um, a defense from the Bible? So we're talking a lot about science and how the science doesn't add up for the Big Bang. But if we were to give a very strictly biblical defense about why God could not have used the Big Bang for creation, how would we do that?
Yeah, okay. So no one's saying that he couldn't have done it in the sense that he lacked the power. God can create in any way that he chooses. But given the information that God has given us, we know that he didn't do it that way because God is not a liar. If he is, we're all in trouble. We can't know anything because he made our senses and our senses wouldn't be reliable. You couldn't know anything if God were deceptive. So uh, if knowledge is possible, then God it doesn't lie. And God has told us that he made in 6 days. It's clear from context those are ordinary, approximately 24-hour days because each one is bounded by evening and morning. In fact, that's how they're defined in Hebrew. Vahi erev, vahi boker, yom echad. The evening and the morning were day one. Was evening, was morning, day one. So that they're defining a day. So, and that's an evening and morning are always literal in scripture, even when they're used in poetic literature. So yeah, each day is an Earth rotation, and stars are made on day four. Earth's made before the stars. Stars are made on day four. Earth's made on day one. According to the Big Bang, this all takes billions of years. It's not 6 days. And stars evolve first, and then the Earth evolves much, much later. Stars are supposed to go back, well, 13, more than 13 billion years, the earliest stars, whereas Earth's only 4.5 billion years old in the secular view. So the order of events is wrong. Um, in terms, the secular order of events does not match the biblical order of events. The secular time scale does not match the biblical time scale. The mechanism, the Big Bang is supposed to be a naturalistic origin scenario. The way that the Big Bang happens is supposed to happen according to the laws of physics. The way that stars come into existence is supposed to be according to natural forces. Bible indicates God spoke them into existence. Let there be lights in the midst of the heaven. So even the mechanism is different. So time scale, order of events, mechanism, all they're different between the Big Bang and what the Bible says. So those of us that have a high view of Scripture cannot accept the Big Bang. It's not the way that God did it. We know that because He's told us in His Word how He did it. And although He doesn't give us a lot of details, He gives us enough details to know that the Big Bang is not it.
Well, and not only that, I don't think there was really any confusion with the Jewish rabbis and others and early church fathers and things like that for such a long time. So this is kind of something new under the sun, of course.
Yeah, that's true. The as far as I can tell, I can't find any evidence of any church father that believed in millions of years up until the 1600s. It wasn't done. It wasn't done. Even those who didn't take Genesis literally, like Origen, or Augustine, depending, his theology changed a little bit throughout his life, but they were young earthers. So this idea of a millions or billions of years old universe, no, that was foreign to the church until again the 1600s, early 1700s in earnest is when that really started to infect the church. And it was and these long age ideas, if you read Terry Morton's Great Turning Point, these long age ideas, a lot of them came from people who didn't want the Bible influencing science. They didn't believe the Bible. And a lot of the church theologians, a lot of church pastors allowed for those ideas because they thought, well, it's not a salvation issue. We don't want to get into that too much. And now look at the consequences of that.
Yeah, that's true. I do have the next question by Carol P. She says, knowing that Big Bang cosmology cannot account for the lack of antimatter in the universe, I read about the proposed solution of asymmetry, the idea that a surplus of matter outlasted the annihilation of the rest of the matter and antimatter. What hypothetical explanation could there possibly be for this kind of asymmetry, and how plausible is it really?
I don't think it is very plausible, but this has always been the theory. It's always been the theory. Once we realized that the universe doesn't have an equal amount of antimatter, the um, the idea is that every now and then. Well, let me back up. Let me back up. We can make matter from energy. We can take the kinetic energy of two particles that are slamming together in particle acceleration chambers, slam them together, and we can create new particles from those, from that energy. We're not creating from nothing like God did. We're creating from stuff he already created. We're making new stuff from it. We can do that. Energy can be converted into massive particles. But every time we do that, every time without exception, we get an equal and opposite antiparticle. So if you produce an electron, you're also going to produce an anti-electron. If you produce a proton, you're going to produce an antiproton. Every time you get an antiparticle. So in antiparticles are like ordinary particles, but their charges are reversed. So an electron has a negative charge. An anti-electron, identical to an electron, except it has a positive charge, also called a positron. Antiproton would have a negative charge, whereas the proton has a positive charge. And every time that energy converts into matter, you always get an exactly equal amount of antimatter. There are no known exceptions to this. But here we live in a universe of matter only that, according to the Big Bang, was once all energy. The Big Bang starts with, it doesn't start with matter. It's too hot to have ordinary matter. It starts with energy, and then as the energy cools, some of it converts to matter. You should have an equal amount of antimatter. This is called the baryon asymmetry problem, because things like matter is baryons, antimatter is antibaryons. The baryon number of the universe should be 0. It's not. It's very high. So the idea is, well, every now and then, when you make matter, you don't get an equal amount of antimatter. So it's symmetry breaking. And this is involved, if you want to look more into this, I'm not going to go into too many details because it gets really boring really quick, but there are certain other symmetries in the universe that occasionally can be broken if you also break another symmetry at the same time. So there's charge and parity, for example, there's charge parity symmetry. And then it was thought that the combined charge and parity always holds. And then they found, well, no, time is another symmetry, forward and backward in time. You can, if you break charge parity, you'll also have to break time symmetry and so on. So the idea is it's one of these symmetries that's not a perfect symmetry. It's occasionally broken. The early versions of these models that predicted that occasionally you'll get matter only when you collide energy, when you make a matter, you only get matter. The earliest models predicted the decay of the proton within a certain time scale. And it's an enormous time scale. So you say, well, how do you test that? Well, you get a bunch of protons. And so even though it's supposed to take however many billions of years for a proton to decay, if you get hundreds of billions of protons, after a year, one of them should decay, if you see what I'm saying. And those numbers are made up, but you get my idea. And they've tested that. They have tested for the decay of the proton, and they found that protons do not decay within the time scale predicted by this original theory. So it's been discarded, and there are now newer theories that predict that occasionally you get matter only, and they also predict certain consequences that have not yet been seen. So I don't think there is a good explanation for the baryon asymmetry problem. It's evidence of creation. God made matter only, and he did it that way because when matter and antimatter touch, they annihilate each other and produce an enormous amount of energy. So we wouldn't be having this conversation if the universe did have an equal amount of antimatter.
Before Steve asks the last 2 questions on our pre-submitted list, which are more theology questions, we've gotten a couple of sciencey questions that we want to throw in, and then we'll wrap up with those last 2 theology questions. But one of them is, what would you say to the idea? Sorry, but my screen just adjusted a little bit. So, what would you say to the idea that what we experience as time is an effect of matter in motion throughout the universe?
Well, yeah, they're connected. I don't know how you would measure time without some kind of motion. Time is some physical condition changing, and it's sort of a measure of the rate of that thing changing. So I do think there's a connection between the two. I don't know if I would define time that way, but it's certainly connected. There's certainly a correlation between time and motion. You can't have motion without time because motion is a change in distance divided by change in time. Well, that's speed. But yeah, motion is a change in position over a change in time. So you need both of those to have motion. So they are connected. They are connected.
Okay, great. And then also, what are your thoughts on why some planets rotate clockwise and some counterclockwise?
Yeah, I think it's an example of the creativity of the Lord to be able to make these diverse worlds out there. I think it's wonderful that we have, even in our own solar system, we have these 8 unique planets, and then we have these dwarf planets as well, and asteroids and things like that. And each one is unique. Each one has its own sort of beauty to it. Now, I think the Earth has a very special beauty to it, but Saturn, magnificent, and Saturn's tilted so that we can see those lovely rings. I think that's wonderful. In the secular model of solar system formation, everything really ought to be spinning the same way and upright, and a lot of planets don't. Jupiter sort of does. Jupiter's pretty well not tilted. It's just very slightly tilted. But a lot of the planets are very strongly tilted. Earth's tilted about 23.5 degrees, which is why we have seasons. That's important for Earth. But Mars is tilted about the same amount, and so it has seasons, even though there's no seed time or harvest there. It still has seasons, summer and winter. And then there's some planets that are tilted so much that it's more than 90%, and so they're effectively rotating backwards, like the planet Uranus. And there's Venus, which you can either think of as spinning backwards or rotated 180 degrees. Those are the same thing, right? So, and I think that's just an example of God's creativity. Venus spins backwards because it's the opposite of what secularists would expect. And it's just an evidence that our solar system was supernaturally created. It did not evolve from a planetary spinning nebula. And again, there's always explanation. Well, something hit Venus and made it spin the other way. I've done some calculations on that. I think that is very unlikely. I think it was created spinning backwards because the number of asteroids that you'd have to hit, it's just astronomically improbable for that to happen. So it's an example of the creative diversity of the Lord.
Okay, so I have two theology questions. The first one is from Eric M, and I guess he also has a second one. But first of all, can the word good in Genesis 1 simply mean that creation is functioning properly as intended, or is there a moral aspect to the context of that word?
Yeah, I think it's both. I think it's both. And you know, at every step of God's creation, he saw that it was good. And then at the sixth day, God looks at, you know, when he finished his work at the end of the sixth day, he looks at everything he made. Behold, it's very good. It's exceedingly good in Hebrew. And so it's a lot. It's exactly the way he wanted it to be, and it's aligned with his perfect character. Today we live in a world that's broken. It's no longer very good. It's still serving God's purpose, but it's no longer perfectly in line with God's moral character because there are what we call sinners on this earth today, and you're talking to one. I just happen to be a forgiven sinner, but so yeah, I think the original creation, though, it was not only exactly the way God meant it to be in terms of its physical properties, but it was morally perfect. God approved of the original creation. And that's what good is. Moral good is that which God approves of and which he blesses. And God certainly approved of his own creation of the universe. So it is both fully functional and morally good as well.
Okay, and Eric's second question is, if the translation, when God began to create the heavens and the earth was without form, is the correct translation and intent of the author, would that change or affect any of your perspective that Genesis 1 teaches the earth must be young?
Okay, so the answer is it cannot be translated that way according to Hebrew rules of grammar, because I've heard people claim this because there are other places in Scripture where you have Bereshith in the beginning of so and so's reign, which you could translate when so and so began to reign. Okay, I get that. So could Genesis 1:1 be translated that way? When God began to create? And the answer is no. And it's because verse 2 uses a vav disjunctive. A vav disjunctive indicates that it is a comment or clarification on the previous statement and also indicates that it's dependent upon it. So verse 2 is a dependent clause. It depends on verse 1, which means verse 1 is an independent clause. And when Bereshith is used as an independent clause, it cannot be translated when God began creating. It's rather in the beginning God created. So it cannot be translated that way. And I've got some Hebrew books that state exactly that. In fact, the accordance software that I have, where I look at Greek and Hebrew on my Bible, that's the first comment that it has on Genesis 1, is that this cannot be translated when God began creating due to the fact that it's an independent clause and verse 2 is dependent on verse 1. So it can't be translated that way.
Okay, thank you.
Okay, well, that brings us to the end of our questions. And this has been an hour of great information. And thank you, Dr. Lisle, so much for coming. Do you want to remind people how they can follow you and your ministry?
Yeah, check us out, biblicalscienceinstitute.com. Biblicalscienceinstitute.com. That's a great resource for you. A lot of great articles in there. The website's free. I still have to eat though, so if you would care to donate to us, we'd appreciate that. We're looking at maybe bringing on another writer, author, speaker. I'm very excited about that, but we'll need a little more funding to be able to do that. So check us out on that webpage, biblicalscienceinstitute.com.
Great. And we are Creation Fellowship Santee, and you can go to tinyurl.com/CF Santee, C for creation, F for fellowship. Santee is spelled Santee, to see a list of our upcoming speakers. In 2 weeks, we'll have Bodhi Hodge with us, who will be giving us a presentation about the biblical perspective of Halloween. So be sure to tune in for that on our webpage. You can also click on a list of archives, and you can see all of the many presentations that we've had over the last 5.5 years. And with that, we're going to go ahead and end our live stream for tonight.